Alright, so in this video I'm going to teach you how to calculate the amount of an excess reactant. Previously up to this point we learned how to use a grid to stoichiometrically find a theoretical yield, and that's a big word. So now what we're going to do is we're going to find an excess reactant. So basically finding theoretical yield using a grid, we've done this in class. In fact, this is the same problem we did in class. If you notice key things in this problem, one of them is that you're given two givens, 10 grams of aluminum and 35 grams of chlorine gas. So you have two reactants. The first thing you have to do is find out which one is the limiting reactant. So how do we do that in class? Two givens that are reactants, you have to do two grids. So what you see here is you see 10 grams for this one and 35.0 grams for that. I take the 10 grams, I run it in a grid, same as class, I got 49.4. I take the 35 grams of Cl, use the stoichiometric grid, we've been doing this in class, I get this one. I realize this is my theoretical yield, I X out the bigger number, because it's my excess, there's no way to actually produce that. The excess is going to be aluminum. So then what I'm going to do is I'm going to go through two steps, real simple steps, to do another grid to figure out how much I actually used. So the key part is you place the theoretical yield into a grid. So I'm going to take this 43.9 grams of AlCl3 and I'm going to use it. So what I'm going to do is I'm going to take the 43.9, so I'm going to go 43.9 grams of AlCl3. Theoretical yield gets dropped into a grid. Then I'm going to run the grid to figure out to the excess reactant. Who's my excess reactant? I identified it was aluminum because this is my limiting reactant. I need to know how many grams of aluminum it's equal to. So whichever one gets X'd out, that reactant is who you're running towards. So I'm running towards aluminum right there, which is right there. So then I'm going to do this. I'm going to just make a grid and convert it. So I go 133.5 grams of aluminum is equal to 1 mole of aluminum. Once I get to that point, aluminum chloride. Aluminum chloride is equal to 1 mole of aluminum chloride. Once I get to moles in the upper part of the grid, like you see here, then I go to the ratio. It is a 2 to 2 ratio. So it's 2 moles to 2 moles from the balanced chemical equation. So I say 2 moles of AlCl3 is equal to 2 moles of aluminum. Then I do 1 mole of aluminum is equal to 26.9 grams of aluminum. At this point, then, I have, if I run the grid and do the math, I end up with 8.85 grams of aluminum. This will always tell you how much of the excess you used. So I took the theoretical yield, which was from here, from the same problem we did in class, and I ran it back to the other reactant, the other given in the original part of the problem. So I have 8.85 that was used. If I go back to the original problem, I started with 10 grams of aluminum. So you subtract the starting amount, 10.0 grams of aluminum, minus the amount of aluminum that was used, 8.85 grams of aluminum according to the calculation that we did in the grid, which means I have a certain amount. I have 1.15 grams of aluminum is what we consider to be excess. That is the amount left over. Key things you have to remember. First and foremost, you're always going to be finding theoretical yield. It's got to be in grams. Once you get that number, if you're asked to calculate the amount of an excess reactant, then you know all you do is you're going to run the grid back to the one that is excess, which you should have been able to identify. By looking at this problem right here, when I look, I notice automatically, do it in green, I know this is my TY, it means goes in the grid. This was X'd out, which means aluminum was my excess. So I'm going to go from here to here using a grid, and that's what you see right here. Once you get that, it always tells you used. Then it just becomes a subtraction problem. Starting amount given in the problem, from the use amount that you use to find at the end of the grid, and then there's the word we need. Bam! At that point, you have calculated the amount of excess reactant. All right? There's going to be a couple problems for homework, and you should be good to go. Have a good evening.